All right, ladies and gentlemen, welcome back. This is the part two of our excretory system, and we're going to be looking a little bit closer at the kidney, and more specifically at the nephron to see how the kidney actually filters the blood to produce urine. Okay, so let's get started here. We're just going to fast forward here to a little visual for you guys. What we're looking at is a longitudinal section through a kidney. It has three parts: our cortex, the medulla, and then the renal pelvis. This little guy here is a nephron, and there's over 1 million of these in each kidney that it's going to be filtering the blood. So you guys can go back and write down the three different spots. You can pause that now to do that. And like I said, each one has over 1 million. Okay, the next one is just a general overview of what's going to be happening in this nephron, and that's what we're going to spend the majority of the time on today, is talking about that. Blood from our body comes into this thing called the glomerulus, and this is the capsule here. What happens is kind of this network of arteries where it kind of gets log jammed in here, and what happens is, if you can zoom out here, there's these little holes in the opening of the capsule where the blood's going to be pushing and pressurizing the contents in there, and if it's small enough it can squeeze through, and if it's not it'll exit the vessel. So when it comes in, it's afferent arterial, and when it leaves, it's the efferent. Once it actually enters the tubule, certain contents of the blood's either going to be absorbed back into the blood, or it'll continue on into the tubule and then excreted out as urine. Here is just the three processes we're looking at: glomerular filtration, tubular reabsorption, and our final one is tubular secretion. So you can come back here, and these are just kind of general overview summaries of what's happening. So after this is said and done, you might want to take a peek back at this for a little bit of a refresher. This is what's happening at each stage. What's going to be entering and exiting. Same thing as before. You might want to come back and look at this visual. You'll see it a couple times throughout, just to have a peek at what's going to be actively transported and passively, and more specifically what's going in and out at each stage. So let's start first with the glomerular filtration. We also call it pressure filtration, and it's in the bomal capsule and the glomerulus, as we already stated. It enters through the afferent arterial and the glomerulus, and if it doesn't enter the tubule, it's going to exit through the efferent arterial. It gets pressurized just like you would see in a garden hose when you put your thumb over the end. Since the same amount of volume is trying to squeeze through a smaller hole, it gets pressurized. It's the same thing in this situation, and if it's small enough, it'll be able to go into the kidney, and if it's not, like formed elements and large molecules like proteins, it will continue circulating in the blood. And then the filtration method creates this stuff called filtrate, and all the filtrate is just anything that actually enters the nephron. So let's talk about the actual process now. The first part is called tubular reabsorption. It happens in a few places: proximal convoluted tubule and the loop of Henle. Proximally convoluted tubule has a lot of microvilli, and we know from digestion this is for increased surface area, for increased absorption. So the more area there is, the more stuff that can be absorbed back into the blood. So these are the things that we actually wanted into the blood that was filtered out, not unintentionally, but just something that we want back. It's either going to be active or passive. One thing that's actively brought back is sodium. And then once it goes through, chlorine can follow because it kind of piggybacks on its proton pump. Water is absorbed back into the blood osmotically, which means through osmosis, which is also passive. And then we have our pH regulation system. Just like before in respiration, if it's too high or too low, H plus and HCO3 bicarbonate can bond with those H pluses in order to raise that pH back up. There's only certain things that can actually be brought back using carrier proteins. One of them is glucose, as we've talked about before. And there's only a limited number of these carrier proteins. So if the amount of glucose exceeds the amount of carrier proteins, then it gets excreted out as urine. So here's a little visual on the side. We are now entering the still tubular reabsorption phase, but this is called the descending loop, I overwrote it here, of Henle. And what's happening here is that there's a very high salt content. And what happens is water leaves the tubule by osmosis. And as we know, if there's a high concentration of a solute, water wants to go there in order to dissolve it. The reason why there's salt is so high, we'll talk about in the next slide here. So the next part is the still tubular reabsorption. This is called the ascending limb, or the limb that's going up. We're breaking it down into two parts, as you can see here. The first part is where NaCl is passively leaves this tubule, and it's because there's low concentration here. And if it's low concentration, it can pass out by diffusion. And as we go up, the concentration increases, and so now we need these things to be actively transported out in order to make that happen. What it has, you can see that it's a little bit thicker, because what it needs are these carrier proteins in order to carry it out, and it needs energy because it needs to go back across the concentration gradient, so it's a little bit thicker there. And the reason why there's so much, or why this is important, is this salt actually facilitates, because this is the layer here, it facilitates this water osmotically leaving the descending limb. So kind of this is build up, and it results in water leaving. The next one we're looking at is something called tubular secretion. So this is not reabsorption anymore. So this is where molecules are going to be coming back into the tubule from the blood. There's no microvilli because there's no need for reabsorption. So no absorption, so you don't need any. Absorption. And things like potassium, creatinine, and any other drugs that we want to get out of our blood can enter here. Also our pH mechanism surfaces again in this section. And this is an active method. The last thing that we're looking at here, this is where we actually have our urine. It's called the collecting duct, or collecting tubule. This is just where anything that's been filtered that hasn't been reabsorbed back into the blood will be excreted, gathered here and then excreted out as urine. So things like water and salt, which we want, but we only want so much. So if certain amounts are too high, if you have too much salt, it'll be excreted out. Urea, other waste products that we don't want will be excreted out here as well. So things that won't be excretion. Just as a little side note here, the difference between secretion and excretion. Secretion needs energy. This one, not so much. We can kind of use these a little bit interchangeably. I'm not going to dwell on the meanings too much. Just we really overview secretion, anything that we actually want. Excretion, things that we don't want, like waste products that's going to be leaving our system. So just to summarize here, structure and function is the thing that we're wanting to look at. So what is the function at each area? Those three processes that we had. So we had our glomerular filtration, and then we had our reabsorption, tubular reabsorption, and then we had our tubular secretion. So make sure you know those ones. Also what's going in and out, so what's going back into the blood, and then what's coming from the blood back into the tubules, and then finally what's our end product, what's going to be in there. So I'd highly recommend right now going back and looking at those visuals. So look at what's actually happening during these stages, what's going in and out, because if you know generally what's happening, it should facilitate better discussion tomorrow. So spend about another 10 minutes trying to actively understand some of these concepts, and if you're totally lost, that is fine. We're going to spend a lot of time on this. So enjoy your night, and Morgan, enjoy your next 4 minutes until I see you in class.